Yes, class. Am I audible to all of you?
Yes,
Abdul,
ma'am.
Izan,
Yes, ma'am.
Khadija, Leena, Shaista.
Yes.
All right. See, class, yesterday we had started with friction and we'll revise the entire friction by kinetic friction itself. So we had studied that friction is basically an opposing force, right? It provides resistance to the motion. Means to the path of motion, to a smooth motion, it will be obstructing it, right? And in three types of frictional force we had studied. Initially, when the object is at rest, the applied force produces a necessary friction force also, that is called as static friction force. Then there's a maximum value of the static friction, which is called as limiting friction. That also occurs when the body is just about to move, it just begins to move, but no motion has actually occurred. Once it has overcome the limiting friction, then friction reduces and that becomes kinetic friction. So kinetic friction or any other frictions formula, law of friction, we have studied, nothing different. Normal reaction is a force that acts perpendicular to the surface of contact, and always it is directed away from the body, not upwards, away from the body, right? And one more, in this figure we'll be having mg as the force. Now we had studied, according to the laws of friction, that frictional force is directly proportional to normal reaction, and here we put a coefficient of friction as the constant. Now, when we're talking about static friction, we'll put an S. For limiting, we'll put an L. For kinetic, we'll put a K. This will show this is coefficient of kinetic friction, right? So these simple questions we had seen. This is also an easy question. Some easy questions, let's see. Then we'll move on to some good questions also we have to discuss. Now nothing else is left. It's just that in friction part, we have angle of repose and angle of friction to be covered. That we didn't do. But before that, let us practice some questions. Suppose this is 5 kg object, mass is this, velocity is 20 meter per second. We have to find out frictional force, right? See, in this case also, if we even right now we have to find out the frictional force. Velocity is given to us. Is it of any use to us? Nothing. We do not require, even if the velocity is given, you require normal reaction, which is equal to mg. Fine, this normal reaction is equal to mg. So your frictional force will be equal to mu mg, that is 0.4 into 5 into 10. Okay, that becomes 20 Newton. This is nothing of use to you, right? Because velocity is not required. We don't want acceleration right now. See, one more question. Then you can write down all these together. Now, this is a question which I was referring and I was telling that objects can be kept in any manner. It's not that you will always get a horizontal case. This is something which is kept, let's say a picture is hung on the wall. So when we'll be performing calculations, it will be vertically. So coefficient of static friction is given to us as 0.2 and we have to find out friction force. What have I told you? Just draw all the forces, draw FBD. We remember we did FBD. FBD was the free body diagram. You have to take the object and draw all the forces acting on it. So if this is the surface of contact, normal reaction will act perpendicular. Gravitational force will act downwards. And this is an applied force by which this object is being held firmly. So friction force is equal to mu n. And normal reaction this time is not equal to mg class. See, this is equal to 20 Newton. So frictional force becomes 0.2 into 20 Newton. That becomes 4. Like this. So be careful with it that you don't have to use normal reaction always as mg. Like in this case, it wasn't. Fine. Note down all these. Then we'll discuss one more question I want to discuss with you. Write this question, class. I'll discuss each part then. This is a long question. So first few people write it down, then I'll discuss it. And meanwhile, all those who will write it, please send the answers of the first part. Written class, let's discuss. Yes, nobody has sent the answer for the first part. Calculate force of maximum static and kinetic friction. See, coefficients are given, kinetic frictions coefficient is given, static frictions coefficient is given, mass is given. This type of question, we have been doing it since yesterday. Nobody has answered. See, this question is similar to what we have discussed though. Okay, Shahista has found. Yes, Shahista. This is correct. And kinetic is also very easy to calculate. Kinetic friction, yes. Just add the unit Newton. See, calculations can be done orally. This is so easy. If the body is kept, this is a mass of 10 kg kept, normal reaction is occurring, downwards weight is acting. We have to find out the frictional force that is acting. So normal reaction is equal to mg, mass is 10, acceleration due to gravity is 10, that is 100 Newton. Now when we have to find out static friction, this is mu s into n. That is 0.3 into 100, which is equal to 30 Newton. And when we have to find out kinetic friction, this is mu k into n, that is 0.2 into 100, that is 20 Newton. Even you could have calculated this directly. See, this is 10, acceleration due to gravity 10, 0.3. So 30, and from this you will get 20. Fine. Now first part, at least all of you should be able to do by now. Is it clear to all of you? Any confusion in the first part? Because this type of question only we have done. Abdul, it's clear to you? Izan, clear?
Yes, ma'am.
Okay. Mariam,
Yes, ma'am.
all right. Now see, second part says that if applied force is 10 Newton, you have to find out static friction. Now see class. Can anyone answer this question? Second part. Any idea? Any guesses? Just let me know in the chat column quickly. If applied force is 10 Newton, you have to find out static friction. See, tell me. I'll let you know. Anyone? Static friction is half. Half? Half Newton. How, Shaista? Any other answer? See, let me discuss it in class. It says that applied force is 10 Newton. Look here. Yesterday we had discussed the entire concept of this. If the box is this, what was the mass? 10 kg, right? Now applied force is how much? 10 Newton. What is kinetic friction? 20 Newton, fine. What is static friction? Static friction is 30 Newton already, right? This is 30 Newton already. In the first part, we have calculated. This is 30 Newton already, right? So if applied, this means this is what? This is one of the values that can be achieved, right? Static friction force is possible. Yes, 30 Newton of force. If I am saying 30 Newton of force is, we have calculated 30 Newton of force for the first part. It means this is possible. This is one of the criteria that yes, static friction can be 30 Newton. But if I'm saying applied force is 10 Newton. So when I say no, static friction is 30 Newton, it means it is 0, 1, 2, 3 till 30 Newton. These values are possible. These values are possible. Last one will be the limiting friction. So if all these values are possible and applied force is 10 Newton, definitely 10 Newton will come under here. So when the applied force is 10 Newton, the static friction, what have we discussed? It's self-adjusting friction. It will automatically adjust itself and frictional force will also become 10 Newton. It will become 11 Newton. It will become 11 Newton. 12 Newton, 12 Newton. Like this, it will achieve until and unless maximum value is achieved. Clear? When applied force is 10 Newton, 10 Newton can be achieved by static friction. How do we know that 10 Newton can be achieved? Because of this first part which we have calculated. That yes, if 30 Newton is being calculated for the first part without any motion, it means 10 Newton will obviously have static friction as it is. Now see, third part C. If applied force is 50 Newton this time, decide whether body will accelerate or not. And if it is accelerating, you have to find out acceleration. Forget acceleration right now. Let's focus on this 50 Newton. Now third part. This is this time 50 Newton. Now, when do we know that the body will move? This force, no, actually, which we have calculated, this is actually a limiting friction because there's the maximum value of static friction that has been given because this is the coefficient. Though we do not know the limiting friction specifically, but we know the ranges, right? 30 Newton. So now the applied force is 50. Force that is applied is greater than the static friction, right? This was maximum, it was 30 Newton, right? So if this side application of force is more, the body will now not remain in static condition. It will move. And once the motion has begun, it means 30 Newton is not being applied. It means 20 Newton of force is applied. That is, kinetic friction will come into action. Fine? Is this clear? See, applied force is 50 Newton. This time 50 Newton, this is greater than 30 Newton. So it means the force has overcome the force of friction. Yes, once the force of friction has been overcome, 50 Newton, now the body has begun its motion. So now the force that will be acting backwards in the opposite direction is kinetic friction. Now we have to find out the acceleration. Draw the FBD and let's say the object is moving towards the right with some acceleration. I have told you the direction of acceleration is taken positive. When we were doing fully mass system, that time I discussed, right? I think yesterday, no, on Tuesday I discussed. Yes, Tuesday. So how will we write? Positive will be this because this is along the direction of acceleration. So 50, or let me write it in variables first. Force of friction of applied force, because this will be positive, this will be negative. Frictional force is acting in opposite direction, is equal to mass into acceleration. This is actually net force is equal to mass into acceleration according Newton's second law. According to Newton's second law, this will be the equation. So what is the net force? F minus Fk. Now substitute in the values. 50 minus 20 is equal to 10A. This is 30 is equal to 10A. Acceleration is 3 meter per second square. This is how we had to solve. All of you have calculated the, all of you have written the question?
Yes.
Okay, write the question. Last part is left, right? Write down the solution. Now angle of friction I'll discuss with you after this. Now see what is meant by angle of friction. See, angle of friction, firstly we have to understand certain parameters in this. Suppose this is an object kept here, this purple, this one isn't, this is an object kept. So normal reaction will be present, downwards, mg will be present, which will be balancing the normal reaction, right? Here, normal reaction is important in this angle of friction. Normal reaction is important. All right. Now, applied force is in one direction, and on the other side, you will have frictional force, right? See, when normal reaction is there and frictional force is there, normal reaction is there and frictional force is there. Both these are vectors. If you are having two vectors, they are making a certain angle. What is the best method that you will use? Parallelogram law, right? The best method to resolve these forces and find the resultant is use parallelogram law. Now, normal reaction is given and frictional force is given. So its resultant will be somewhere here. This is the resultant which I have drawn. Fine. Now, what is angle of friction? Angle of friction, the angle that is formed here, no, between the normal reaction and the resultant. This is called as the angle of friction. What is this resultant? This resultant is resultant of friction and normal reaction. Now come. It is the angle which resultant of normal reaction and friction makes with the normal reaction. If you will just learn the definition, no, it becomes very confusing. It is the angle with resultant of normal reaction and friction makes with the normal reaction. If you have the diagram in front of you, if you have the figure in front of you, it will be easier for you to relate. Normal reaction and frictional force, their resultant is this. And the angle that this resultant makes with the normal reaction. This is it, which you have to remember. Now, for the derivation purpose, the derivation of this is usually not asked. Definition is asked. Definition is asked. Now see, I have named this triangle as OPQ. Now look here. In this triangle, OPQ, if I try to find out tan theta, what will it be? See, this is the triangle, OPQ. If I want to find out what is tan theta, this is going to be tan theta, QP by OP, perpendicular by base, QP by OP. Yes. What is QP? QP is actually depicted by friction force, right? Both these, this and this, they are parallel, right? This and this, they are parallel. So QP is frictional force. What is OP? OP is already the normal reaction. OP is N. Now, what is the formula of friction? Mu N divided by N. N will get cancelled. So mu is equal to tan theta. This is a very common formula used in friction. Note it down, then one more angle I have to discuss with you. But first write angle of friction, then I'll discuss. Now class, coming to angle of repose or sliding. So this is the last topic from friction. Now angle of repose means what? See, suppose I have kept this block mass M on this inclined plane. This inclination has angle theta. Fine, or let me erase this. Now look, this is the mass M kept. Now normal reaction is there. This is the friction force. Here resultant will be there. This angle is what? Which is this angle class? This angle. This is friction. This is normal reaction. This was the resultant. Resultant with normal reaction. Yes, Lena?
Angle of friction.
Angle of friction. Very good. This is angle of friction. So if this is angle of friction, then what is meant by angle of repose or sliding? This means when the object is kept here and we have left it. So it will slide down on the inclined plane. Some force will occur, it will slide down. So when it will slide down, friction force will act in the opposite direction. Friction force will act upwards. Right? This object, this force is acting downwards. Friction force is acting upwards. Yes? So as soon as it begins to move, now whatever angle is being formed here, that is what is called as angle of repose. So minimum angle of inclination at which body just slides down. Suppose I have kept it like this. The body is not sliding. I have increased the inclination. Now the body just slides, just begins to slide. It means this is the angle of inclination. This is the angle of inclination. Angle of repose or angle of slide. All right. Now see, regarding this. Now, this I just wanted, this we haven't discussed on inclined plane. That's why I wanted to discuss over here. Gravitational force will in any ways act downwards, right? Normal reaction will be perpendicular to the surface. So that's why normal reaction is occurring upwards. Friction force is always opposite to the direction of motion. So it is acting backwards. Here the direction of motion is there, right? So everything, whenever you are doing resolution, whenever you are having an inclined plane, you have to follow these two rules: along the plane and perpendicular to the plane. All the forces should act either along the plane or perpendicular to the plane. Now look here. This is object. Perpendicularly, always you will have normal reaction. I told you when the object was kept like this on the wall, normal reaction became like this. When the object is kept like this, normal reaction becomes like this. Normal reaction is always perpendicular. Fine. Now see, it will move in this direction. So friction acts in this direction. These two things. But gravitational force won't act like this, no, inclined. It will always act downwards. So this is perpendicular to the plane. This is fine. We don't need to resolve this. This is along the plane. We don't need to resolve this. This is also fine. But this is along y-axis. This is not either along plane or perpendicular to the plane. Whichever force is acting, what you have to do, you have to perform resolution. Now look, if this is theta, right? If this is theta, look here class. This is 90 degree, here perpendicular. So this becomes 90 minus theta. Learn it once because you will not be remembering and doing it twice. This is theta. This is 90 degree. A triangle is there. So this becomes 90 minus theta. This entire is also perpendicular. So 90 minus theta and this is 90. So this will be theta. Clear? Theta 90, 90 minus theta. This is like 90 minus theta. This is what? So it's if this is x, 90 minus theta plus x is equal to 90. This will cancel, x equals to theta. So this is actually theta. Remember this. From now onwards, don't waste your time in calculating which angle is this. If this is theta, This is 90. 90 minus theta. This entire is 90. So this will be theta. And how have we done resolution of vectors? Axis with which the angle is made receives cos theta. So this becomes mg cos theta. Perpendicular to this is mg sine theta. All the resolution of vector is done. See, this is also perpendicular to the plane. Both of these are parallel. One more thing, let's write friction force. Friction force is mu n. Now, can you see? Normal reaction is balancing mg cos theta. Normal reaction is balancing mg cos theta. So, friction force is mu mg cos theta. Fine. F is equal to mu mg cos theta. N is equal to mg cos theta. Now, what is this is by this equation 1. Secondly, what frictional force is balancing? Frictional force is balancing mg sine theta. The way normal reaction is balancing mg cos theta, frictional force is balancing mg sine theta. Right? Forget this mu mg cos theta. Just check it like this. Normal reaction is balancing mg cos theta. Frictional force is balancing mg sine theta. Second equation. Take the ratio. So F is equal to mg sine theta. This is divided by n. This is mg cos theta. So mg will get cancelled. So sine theta by cos theta, this will become tan theta. Frictional force is mu n divided by n. Again, what are we getting? Answer is same. Mu is equal to tan theta. So from here, you can always calculate theta. Theta will be tan inverse mu. This is the angle of repose or angle of sliding. Questions we have noted down. Let's practice some questions also based on this. In this question, you have to find out normal reaction and friction. We have to find out limiting friction's coefficient is given to us. See, mass is 10 kg. It is kept on an inclined plane. Angle is given as 37 degrees of inclination. Normal reaction. Firstly, draw all the forces that are occurring. Normal reaction is acting upwards. Mg is acting downwards. It will obviously slide downwards. So, frictional force will act upwards. Now, if this is 37, this will also be 37. So this becomes mg cos 37 degrees. And this becomes mg sine 37 degrees. Now we'll be able to find out everything. First part says normal reaction. See, normal reaction is equal to mg cos 37. One thing, class, see, we already remember the trigonometric values of 30 degree, 0 degree, 45 degree, 90 degree, 60 degree. Yes. 37 degree and 53 degree. This also you need to remember. Just for cos and sine. See, let me write it down separately. You write it in your register. Cos 37 degree, this is equal to 4 by 5. And cos 53 degree is equal to 3 by 5. Then sine 37 degrees is equal to 3 by 5, just opposite to it. And sine 53 degrees, this is equal to 4 by 5. So sine 53 is equal to cos 37 and cos 53 is equal to sine 37. All right, these are the values that you have to remember because 53 and 37 will be used somewhere. Now normal reaction is equal to mg cos 37. So this is equal to mass is 10, g is 10, cos 37 is 4 by 5. This becomes 2, normal reaction becomes 80. This is the answer to the first part. Second part, friction. Friction force we have to find out. See, we already have normal reaction with us. We have mu with us. So for the calculation of friction, this is the first part. Second part, frictional force is equal to mu n simply. Mu's value is 0.3. This is 80, which is equal to 24 Newton. Fine, note it down. Please write this also, class. This will be used. No value will be given to you. 53 and 37, you will find it. Okay, Zan, no issues. One question only I have to discuss. You can leave. Fine class, all those who have completed, you people can start leaving. Now in the next class, just listen. In the next class, we'll be studying circular motion. Circular motion we'll study. Now, circular motion, we'll not study just the part that is involved in laws of motion. The circular motion portion, the basics of circular entire kinematics we'll be studying here of rotation from work energy, but entire from your 11th physics. So all together we'll be studying circular motion separately. All right, so when we'll be coming to rotation motion, we'll not be discussing angular displacement, formula of angular velocity and all that we'll be covering from the next class. And then friction force will also come into action, rest of the details. Okay, class. Thank you so much. Next week, let's continue. Any doubts if you have, you people can let me know.